Alright, good afternoon everybody. This is going to be the statics of the spring 2021 semester exam 2 review. We're going to be going over chapter 4, chapter 5, and chapter 6. So the problems that we're going to go over for today are number 4.23, 4.28, 5.3, 5.8, 6.9, and 6.10. So to start things off, we're going to start off at 4.23. So 4.23 gives us these two different plates, case A and case B. There is a pin joint at A and a roller point at B for case 1, case A. And at case B, there's a pin at A as well, but there is a roller joint at an angle of 30 degrees from the horizontal at B. So those two are going to be the really big differences, otherwise the forces, the dimensioning is all the same. So the question asks us to find the reactions at A and B for both cases. So to start it off, let's draw a free body diagram. So for A, we have the 50 pounds going down, 4 inches from the left. We have the 40 pounds going to the right at the top corner, 10 inches away from A. We have our pin reaction at A, so it's AY and AX. And we have our roller support at B, which is just a vertical reaction, so we have BY. For case B, we have the exact same forces, the 50 pound, 40 pound, and the pin reaction at A, but for B, it's at an angle of 30. Now, they gave us it from the angle from the horizontal, but you can also write that out because of the way the angle is from the horizontal. It's facing into the plate, and so this is going to be our reaction, 30 degrees from the vertical. Okay, so let's start off with our solution. I'll zoom out so we can still see the free body diagrams. So we'll start off with section A. So we can just start with the sum of forces in the x direction equal to 0, positive to the right. We have AX plus 40 pounds is equal to 0. We go ahead and solve. AX is, negative 40 pounds. Alright, sum of forces in the y equals 0. Vertical up is positive. We have AY plus BY minus 50 pounds is equal to 0. We have two unknowns we can't solve, so we need to take a moment. Let's take a moment about the spot that's going to give us, or take away the most unknowns. So at this point, it's going to be A equals 0. Staying counterclockwise is positive. We get BY times 20 inches minus 50 pounds times 4 inches and negative 40 pounds times 10 inches equal to 0. Alright, now we can solve for BY. BY comes out to 30 pounds. And now we can plug all those numbers back in to get AY. AY is equal to 50 pounds minus 30 pounds. So AY is 20 pounds. Pretty easy, pretty straightforward, nothing too big, nothing too crazy. So now we'll do case B. So same thing, sum of forces in the x direction are equal to 0. Positive to the right. We have AX plus 40 pounds minus BY times the angle that it's occurring at. So this one's sine 30 is equal to 0. The reason why it is sine 30 is because we're looking at it in the x direction. Remember, this is our free body diagram of case B. So we're looking at only in the x direction, while BY is going to the left in the x direction. And the angle that it's associated with going in the x direction is the sine of 30. I know how you want to say cosine is with x and sine is with y, but when you flip the triangle, now the sine of 30 degrees is with the x direction and the cosine is with the y. So just watch out for that when he gives you a different angle. Okay, now we have too many unknowns, we can't solve for that. Let's go ahead and do the sum of forces in the y direction. It's equal to 0. Positive going up. We have negative 50 pounds plus AY plus BY. Now this one's the cosine of 30 is equal to 0. Again, two unknowns, two equations, two unknowns. We could make a matrix, or we could just take a moment. So let's take a moment about A. Take away a lot of those unknowns that we don't need, or we do need, but we can get them out of our way. We do by times the cosine of 30 degrees times its distance, 20 inches, that's perpendicular, minus 40 pounds times 10 inches, and minus 50 pounds times 4 inches, equal to 0. Now we can solve for by. By is equal to 34.6 pounds at that angle of 30 degrees that they gave us. Alright, now we can plug back in. AX is equal to negative 40 pounds plus 4.6 pounds at the angle of sine 30. AX could come out to negative 22.68 pounds. Now we can solve for AY. AY is equal to 50 pounds minus 34.6 cosine of 30. AY comes out to an even 20 pounds. Alright, not too bad. So basically, all you're doing is take a sum of forces xy, and you take your moment. Only thing you have to watch out to is these weird angles that he might give you. There's a really good chance that you'll see one of these problems on the exam. More like case B, just because it's a little bit harder, and actually we'll try to test you a little bit, because this one, case A, is too easy. So just watch out for it, take your time, and remember those angles. Alright, that is it for this problem. On to the next. Alright guys, good afternoon. We are going to be going over Chapter 4 again for Exam 2 review. This one's going to be our number 4.28. This one will be in your book. So this is going to be another frame. We have a pin at C and a roller at A at some angle alpha. We have a 300 Newton force in between the center of C and B, and another 300 Newton force at the end of B, all going to the right. The question asks us to find the reactions at A and C when alpha is at 0 degrees and alpha is at 30 degrees. Being that alpha is going to be at 0 degrees, that's going to be a pretty simple problem. So I'm not going to do it. Instead, I'm going to do the harder one for y'all. So I'm going to do it though alpha is at 30 degrees. So to start it off, we need to draw our free body diagram. So we have a pin at C, so we have a CY and a CX, and we have our reaction at A. Now it's going to be at some angle alpha. If you look right here, they have it given to us at alpha from the horizontal. But when it's at an angle on a roller, it's going to be a reaction force that's perpendicular to the plane that it's going to be sitting on. So that is why we have a force right here perpendicular to that plane. So law of interior angles, if this is alpha here at the horizontal, this one right here from the vertical will also be alpha. Now these points that I have drawn out right here, this is going to be to help demonstrate on how we're going to do the moment equation here in just a minute. So to begin this problem, all we need to do is to start taking our sum of forces. So sum of forces in the x equal to 0. Always state which way you're going to say is positive. We have a positive Cx. I'm going to combine the 300 Newton forces to be a total of 600 Newton force. And we have our force A going to be at the x direction, so it's going to be at sine alpha is equal to 0. Now take our sum of forces in the y equal to 0. We're going to state that positive up. We have a positive cy and a positive fa cosine alpha, all equal to 0. Now we have two unknowns and two equations. We cannot solve for anything right now, so we need to take a moment. So we're going to take a moment, take a moment about the point that's going to take away the most out of amount of unknowns. So we're going to take it about C, all equal to 0. I'm going to say that counterclockwise is positive. So we're going to have a 300 Newton force going in a clockwise rotation. That's going to be at, I'm going to go ahead and convert it to 2 meters, 0.2 meters. We're going to have another 300 Newton force at 0.4 meters. And now we're going to have to worry about F of A. Now this is where this is going to come in. So at F of A, if we're looking at a force going up in the y direction, our perpendicular distance is going to be in the x direction, so it's going to be at this 0.8 meters right here. We're going to have a negative force in the a direction, because it's going to be a clockwise rotation. Now this is going to also be with sine alpha times 0.8 meters. Now we're going to have to worry about the x, or the force of A, in the x direction or y direction. So we have a force going in the x direction. Our perpendicular distance is going to be in the y direction. That's going to be causing a counterclockwise rotation. So it's going to be a positive f of A cosine of alpha times that perpendicular distance, which is going to be 0.4 meters, all equal to 0. Simplifying it down and solving for f of A, we pull f of A out as our common factor. It's all going to be equal to, go ahead and simplify those 300 newtons times the 0.2 meters, and the 300 meters times newtons times 0.4 meters. That's going to be a negative 180, moving it over to the side that we need it on, Newton meters, all over negative sine 30 degrees times 0.8 meters plus cosine 30 degrees times 0.4 meters. We get an f of A to be, scroll down to where I actually have my answer, because I have this all written out already ahead of time. We get 365.24 newtons at force A. Now we have A, we can solve for Cx and Cy. Solving for Cx, all you do is just take out your common factors, move them all to the right side, get Cx by itself. Solving for Cx, we get negative 782.62 newtons. Note that it says it's at a negative, so we assumed our direction wrong, but that's perfectly fine. The math comes out to what we need it. We find Cy. Solving for Cy, we get Cy to be a negative 316 newtons. Also, we assume that that direction was wrong as well, but that's okay, as long as we got our values. So chapter 4, as long as it's a 2D frame, they'll be pretty quick, pretty straight, easy. My best recommendation to you is, if you have a really good grip on chapter 4 and a decent grip of chapter 5, but not in chapter 6 for the exam 2, go ahead and start the exam on chapter 6, because that's going to take up most of your time. Also, as a side note, do be sure to write your name on every single page that you do for the exam, including the cover page that he gives you that has the problems written on it. Write your name on every single page, even if you have to put a page number on every single page. That will help you keep your track, and that helps Dr. Jackson know where your papers are at, so that way he doesn't get lost and confused and possibly gives you a bad grade because he couldn't find your name on your papers. And also, if he gives you a question that's a freebie question, just a free give me 4 to 6 points, take advantage of it. Go ahead and do those free points, and you will be thanking yourself later. Other than that, that is it for chapter 4. We will be moving on to chapter 5 in the next video, so please stay tuned. Thanks. Alright guys, welcome back to chapter 5 of exam 2 for statics review. We're going to be going over number 5.3 in your book in chapter 5. This problem is going to be a rectangle and a triangle combined, as shown here. We need to find the centroid. So what we need to do is distinguish on how we're going to break down these components of this picture, so that we can simplify it down and actually solve for everything. So the best form for this one would be to separate them into a rectangle and a triangle. I'm going to label my rectangle as 1 and my triangle as 2. So we have 1 plus 2 Go ahead and draw our rectangle. I'm going to draw mine nice and pretty with straight lines. Plus our triangle, which is just pretty much an upside down right hand triangle. Nice and easy. Now, I have right here this color code right here. So blue dot is going to be our local centroid, and our red dot is going to be our global centroid. A global centroid can be found in the entire picture. So we're looking for the global centroid of this entire picture. The local centroid is going to be finding the actual center of each individual shapes. So we know that the local centroid of a rectangle is going to be in the center, half of the width and half of the length. And on a triangle is going to be 2/3 of the base or in the height. So most likely somewhere about right there. So same thing for over in the big drawing. Those are going to be our locals. We can guess that our global is probably going to be somewhere at around there. This is going to help us be sure that when we do our math, our assumption's correct. So the next step that I like to do is I go ahead and solve for my areas. Go ahead and get them out of the way. So an area of a rectangle is pretty straightforward. Length times width, 120 times 100, all in millimeters. We get 120,000 square millimeters. Now we have a triangle. Our triangle is going to be pi r squared over 2, which is going to be, oh, sorry. I was thinking of a circle. Don't know why, but I was. Our triangle is actually going to be base times height over 2, which is going to be our 60 times 120 over 2. Our area for that one, I think it should be 3,600. Yep, 3,600 squared. Now I'm going to write that out a little bit nicer for us to see. So our area for 1 is going to be 120,000 square millimeters. Our area for 2 is 3,600 square millimeters. So now that we have our areas, we can find our local x bar and y bar for each individual shape. So to find our local x bar of our rectangle, it's going to be where the local centroid sits at the center from the x direction of our origin. Make sure we know where our origin at. Make sure that when you do have your stated origin, that is where you start for every point. If you can't have an origin stated here and then start referencing from here, you'll have all your numbers mixed up and you will get the problem wrong. So every time you start at the origin. So starting at the origin, to find our center at the x of the rectangle, we go out halfway of our length or our width, which is half of 120, so it's going to be at 60. And that's going to be our x bar. 60. Now we need to find our y bar. Our y bar is going to be on the rectangle, starting from the origin, go up halfway up on the rectangle to find there. So we have to go up the full amount of 60 plus half of the 100. So it's going to be 60 plus 50. We're going to have our y bar be at 110 millimeters. So now that we have those, we can go ahead and do the triangle and go ahead and get it out of our way as well. To find the triangle, we need to break these into thirds. So we're going to have our first tick, second tick, third tick. Same thing for here. We're going to have first tick, second tick, third tick. Now to find our x bar and y bar of the triangle, our local x bar of 2, if we look at it, on our x, we need to take 1/3 times the amount of distance it takes in the x direction, which is going to be 120 millimeters. So our x bar of 2 should be 40 millimeters. We're going to do the same thing for our y bar of the triangle. Now, looking at the y bar, we have to go up in the y direction. So now we've gone up 2 ticks. Instead of on this one, we only went up 1 tick. So if we go up 2 ticks, we need to do the equation 2/3 times our distance in that one, which is going to be 60 millimeters. Which, double checking the math, 2/3 times 60, we're going to have it also be 40 millimeters. Okay, now we just need to take our local x bars times our areas of each individual one. I'm going to go ahead and shorthand this, zoom in so I can write it a little bit easier for you. We're going to have our x bar times our area going to be 7.2 times 10 to the 5th. Now note right here, it's going to be millimeters cubed because you're going to have millimeters times a millimeter squared. Our y bar times our area is going to be 1.32 times 10 to the 6th. Doing the same thing for our triangle, we're going to have 1.44 times 10 to the 5th and 1.44 times 10 to the 5th as well. Okay, so now that we have our table completed, we can go ahead and start summing our forces in our areas. So our sum of areas is going to be 15.6 times 10 to the 3rd. It's going to be square millimeters. Our sum of our x bars times our area is going to be 8.64 times 10 to the 5th. That's going to be cubic meters. And our sum of our y bar times our area is going to be 1.464 times 10 to the 6 cubic meters as well. Now that we have those values, we can use these equations right here given to us from the book to solve for our global x bar and y bar. So, solving for a global x bar, we just take our sum, this is supposed to be sum in between those. It's going to be sum of our x bars times our area over the sum of the area. Doing that math, we get our x bar to be 55.4 millimeters and our y bar to be 93.8 millimeters. And that is it for this problem. The biggest thing you got to watch out for is to know where your origin at, where you're starting on your origin. That is going to be your big kicker. So, now that that one's done, we'll move on to the next problem, which is going to be 5.8. 5.8, based off what we're looking at right here, is going to be a semicircle minus a rectangle. Again, we're finding the centroid, so I'm going to label the semicircle as 1 and our rectangle as 2. So I'm just going to do a vague drawing of them right here. Semicircle, which is 1, minus, because this is a hole, this rectangle is being taken away, minus our rectangle. Drawing it nice and neat. 2. Now that we know those, we start taking our areas. So area of 1 of a, now the area of a semicircle is going to be pi r squared over 2. That was the equation I was trying to use earlier, which is going to be pi times our radius, which is 38 inches, squared all over 2. We get area 1 to be 2,268.2 square inches. Now we need to find our area of a rectangle, which is going to be 20 inches times 16 inches. We get area 2 to be, but keep in mind we're subtracting this, so it's going to be a negative 320 square inches. Knowing our values, let's go ahead and start plugging them into our table. We get 2,268.2. Keep in mind this is square inches, and negative 320 square inches. Now we need to find our local y bar and x bar for both of these. So the local y bar for a semicircle is going to be somewhere about right there, and the local for rectangle, of course, is going to be about the center of half of the width, half of the height, or half the length. Our global centroid for this problem is probably going to be somewhere about right here on the main picture. Because we're subtracting this rectangle out, the larger portion of the circle or semicircle is going to be to the right, so that's more likely where our center is going to be. So continuing on, we need to find the center, or sorry, the x-bar, which is going to be our local centroid, and the x direction of a semicircle. This part you're going to have to refer to the back of your book or the chart that he will give you on the exam. It's going to give you to find the x-bar, y-bar, and your areas of all different kinds of shapes. So referring to the chart, on a semicircle, it is 0 for the x, and we can prove that by our origin being right here at the center. So it's going to be 0 in the x direction. Now we need to find it in the y direction. To find it in the y direction, our y bar of 1 is going to be 4r over 3 pi. Solving that out, we get 16.13 inches. Those are also inches. Alright, now we're going to do the same thing for the triangle. Or sorry, not the triangle, the rectangle. Now in the rectangle, we have the origin right here, and we have to go to the left, half of 20. So we're going to have a negative 10 inches in the x direction. Now we need to go in the y direction to find the local centroid, which is local is going to be here, and the local, this one's going to be here. So that's going to be half of 16, so we're going to have 8 inches. Now we need to find our x-bar times our area. On the semicircle, it's going to be 0. And on the y-bar, it's going to be our 16.13 times 2,268.2. We're going to get 36,581 cubic inches. Solving again for x-bar times area on the second one, which is our rectangle, we get a negative 32, sorry, it's going to be a positive 3,200 cubic inches. And on the y-bar, it would be negative 2,560 cubic inches. Alright, now that we know those, let's take our sum of our areas, which we get 1,948.23 square inches. Sum of our x-bars times our area, we get 3,200 cubic inches. Taking our sum of our y-bars times our area, we get 34,021 cubic inches. Now we got to take our main equation, which is our global x-bar, times our sum of our area is equal to the sum of our little x-bar times our area. Same thing for our y-bar. Sum of the area is equal to sum of our little area, y-bar times our area. Solving those equations out for x-bar and y-bar, we get x-bar to be 1.643 inches and our y-bar to be 17.46 inches. And that completes Chapter 5. So Chapter 4 and Chapter 5 are pretty straightforward as long as you kind of know what you're doing and you keep calm and just watch your origins for your Chapter 5. Chapter 4, watch your angles, make sure you know how you do your sine and cosines even when your perfect triangle's flipped around, and you will be just fine. So if you have Chapter 4 and Chapter 5 really good in your books and you know it really well, but you struggle on Chapter 6, start the exam at Chapter 6 problems, which is going to be a truss. Those problems are going to take you longer. So that completes Chapter 5 Exam 2 review. We're going to start Chapter 6 in the next video, so stay tuned, and we'll see you then. Alright guys, this is going to be Chapter 6, number 6.9 for Statics Exam 2 review. So this is going to be a truss system. We have a pin at C and a roller at F. Given to us also is a 8 kilonewton force going down at A. They're asking us to find all of the forces in each member. So we need to find a way to do this. So we need to know if we need to use method of joints or method of sections. Now, on the method of sections, you are restricted to only being able to make a cut through only 3 members. So, if we tried to make a cut in this truss, if we do one right there, we go through 1, 2, 3, 4 members. So we cannot do that. Okay, so let's try another direction. So say let's make a cut right here at this angle. Well, same thing. 1, 2, 3, 4. So now we're seeing a pattern. It looks like method of sections is not going to be working for this system, so we are going to have to do it by method of joints. So we start off by making our free body diagram. Our free body diagram, we have a pin at C, so we have a CY, CX. We have a roller at F. I have it stated as a positive in the X direction going to the right. And we have the 8 kilonewtons down. I went ahead and drew this angle theta from the horizontal. We'll be using that later to find our interior angle. So to start it all off, we need to take our entire system, sum of forces. So we're going to take sum of forces in the X equal to 0, positive in the positive right direction. We have Cx plus f of x is equal to 0. Our sum of forces in the Y is equal to 0, positive in the vertical up direction. We have a negative 8 kilonewtons plus Cy is equal to 0. We can solve for Cy right now. Cy is 8 kilonewtons. But we still don't know Cx and the Fx, so we need to take a sum of our moments. We're going to take a moment about C, saying that counterclockwise is positive. We're going to have our force in the x direction times its perpendicular distance, which is going to be 3.2 meters, plus our 8 kilonewton force times 6 meters, all equal to 0. Now we can solve for f of x. F of x is going to be a negative 15 kilonewtons. So it's going to be to the left instead. Now that we know f of x, we can solve for c of x. Solving for cx, we get a positive 15 kilonewtons. Okay, so now that we know our reactions, we can start using method of joints. So when you start these off, you need to start at the joint that you know the most amount of forces. So right now, our point C, we know more than anything else. We know this one and this one. All we need to find is force BC and force CE. So we're going to start off at joint C. Always label which joint you're going to from first. That way Jackson knows when he's grading it to know where you're at. So label it C. We have our force in the CUI. We have our force CX. Now remember, always draw your arrows going away from the joint. Unless you know the force. So like on this one, we know that it's 8 kilonewtons positive, and Cx, which is 15 kilonewtons positive. If you have an unknown force, which is our members, draw those away. So we have force CE, and we have force BC. Now we have our free body diagram set up for our joint. We need to take our sum of forces in the x and the y. Sum of force x equal to 0, positive in the x direction. We get a negative force BC plus 15 kilonewtons is equal to 0. Solving for that one, we get BC is equal to 15 kilonewtons. Now it's positive, that means it's in tension. That is our first member. Now we'll take our sum of forces in the y is equal to 0, positive in the x direction, or positive in the vertical y. We get a negative F CE plus 8 kilonewtons equal to 0. Force CE is equal to positive 8 kilonewtons, which is also in tension. Okay, so first two members are already knocked out. So now we need to go to the next joint that we know the most amount of forces. So for this one, we have our reaction at F, so we're going to do joint F next. Again, state which joint you're doing your analysis from. We have point F right here. We know our direction of our f of x, which is a negative 15 kilonewtons, going to the left. We don't know our force Fe, so force Fe. And we don't know this force at this angle, which is force dF, which is going to be at that some angle theta. Now to find theta, all we need to do is look at our triangle. Our triangle, we have 1.6 and 3, so we can find our angle right here, which is beta. So beta is going to be inverse tangent of 3 over 1.6. That will come out to 61.93 degrees. Now we need to find our theta. Our theta is going to be 90 plus 61.93 minus 180. We will get a theta to be 28 point, I believe it's 1 degrees. Now we can do our sum of forces. Sum of forces x equal to 0, positive in the right x direction. We have a negative 15 kilonewtons minus our force dF times our cosine of theta equal to 0. We can go ahead and solve for a force Fd, or dF. Force dF is equal to a negative 17 kilonewtons. It's negative, so it is in compression. Now take our sum of forces in the y direction is equal to 0. Positive in the vertical up direction. We get force Fe plus force dF sine of theta is equal to 0. Knowing theta and everything else, and we know force dF, we can find force Fe. Force Fe comes out to 8 kilonewtons positive, so it's in tension. Okay, we're moving right along. So now we know a total of what, four beam members so far. Now we can move on to our next joint. So we now know this member, this member, this member, and this member. So we need to take our next point that we know the most. We have the most knowns. So that is going to be joint E. Joint E. So we'll make our dot saying that this is going to be at E. Drawing our forces away, we get our force Fe force Ce. We have this force at angle BE. And this force member DE. Now we need to know what this angle is right here. I'm going to label it as lambda. Now, to find lambda, all we have to do is look back at our triangle. It's going to be inverse tangent of 1.6 over 3. We're going to have lambda come out to also 28.1 degrees. You can also look at this just as your law of triangles and your law of interior angles. It's also going to be the same from what we found for theta. It's just moved up. Knowing that, we can start doing our sum of forces in the x and y. sum of forces in the x, positive in the x direction and to the right, we have a negative force dE minus our force BE cosine lambda equal to 0. Now we have the sum of forces in the y direction, positive in the up direction. We have force CE minus force FE plus force BE sine of lambda is equal to 0. We go ahead and plug in on our f of y equation because we know our force CE and force FE. That will be 8 kilonewtons minus 8 kilonewtons plus force BE sine lambda is equal to 0. That will come out as force BE is equal to 0. Now we know force BE, we can solve for FDE. Force DE will also be 0. Okay, now going back up to our free body diagram, we now know that joint and this joint. So all we have remaining is AB, BD, and AD. Now if you look at this triangle, we have an 8 kilonewtons going down, which is going to cause this member going to be in compression, this member be in tension. However, this guy is going to be pushed and pulled from each direction. Because of so, this will force BD, member BD, is also going to be a 0 force member. If you are any kind of confused by that, feel free to go ahead and do method of joints on one of those. You can do a method of joints about B. You'll have two unknowns and two knowns, and you'll find that force BD will come out to 0. Okay, so that leaves us down to one more joint, joint A. So looking at joint A, we have a negative 8 kilonewtons going down. We have our force AD down to the right, and our force AB directly right. Now, this angle is also going to be lambda, which is also theta. Solving our forces in the x and the y. We have force AB plus force AD cosine of lambda is equal to 0. We can go ahead and solve for force AD is equal to negative 17 kilonewtons. And that is in compression. The reason why is because force AB is also equivalent to BC. This force member right here is also going to be the same force member right here. That's what it's going to be experiencing. We said that BC is 15 kilonewtons. That is why I have that number right here. Force AB is equal to force BC, which is 15 kilonewtons in tension. And that is it for this Chapter 6 problem. Now, I know I kind of went through that fast, and I kind of did some assumptions that you probably won't see right off the get-go. So, feel free to do continuing on and do joint B and then joint A to finish out the problem, so you can see how you get 0 and how you get your force AB is also equal to force member BC. Okay. All right. That is it for this Chapter 6 problem. We have one more Chapter 6 problem to do, so stay tuned for the next video. Alright guys, welcome to the last problem of Chapter 6, Exam 2 Review. This is going to be Chapter 6, number 10. We have a pin at A and a roller at E. We have 12.5 kilonewtons at A, B, C, and D. They are asking us to find the force in member BC, FC, and FG. So Jackson is going to give you a problem very similar to something like this, or any type of truss system that is going to ask you for 3 members at a time. That way you can do method of joints and or method of sections, so you have the option. So drawing our free body diagram, we have our force in the AX and AY, and we have our force EX. We have our 12 kilonewtons at A, B, C, and D. So now we need to know if we can take method of sections. So we're going to do some cuts, see which one works best for us. So we're looking for force member BC, FC, and FG. So if I took a cut right here at cut 1, I could do that, but I'm not going to find my force BC, FC, and FG very easily. But if I take my cut at cut 2, I cut right through the center of the beams that I'm having of interest of. Now I can find them in one shot. Now the choice is, do I want to take all my analysis from the left or all my analysis from the right? You choose the one that's going to be easiest for you using method of sections. We are going to look at this problem from the right. So let's go ahead and do our sum of forces of the entire system. Get those out of our way. We have AX plus EX is equal to 0. Sum of forces in the Y is equal to 0. Positive in the up direction. AY. I'm going to combine all of those 12 kilonewton forces as it to be a total, moving it over to the right hand side as well, 50 kilonewtons. But now I have AX and EX that I don't know for, so I need to take a moment. So in the moments, I'm going to take it about A equal to 0. It's going to be positive in the counterclockwise direction. We have EX times 2.5 meters minus 12.5 kilonewtons times 2 meters minus 12.5 kilonewtons times 4 meters minus 12.5 kilonewtons times 6 meters, all equal to 0. Simplifying now and solving for EX, we get EX to be a positive 60 kilonewtons. Now we know AX, we can find AX. AX is going to be a negative 60 kilonewtons. Okay, now we can do our method of sections. So section at cut 2 is where I'm going to label it as, so that way we know where we're going. And I'm going to go ahead and redraw the new part of our system. We have our force in member BC. We have force in this member FG. And this force member FC. This is point C, point G, point D. We have a 12.5 kilonewton force at C and a 12.5 kilonewton force at D. From the dimensions in the problem, this is 2 meters, and now we need to go ahead and find what this length CG is. To find length CG, all you need to do is Pythagorean theorem and solve for that length. We get our length CG is 0.833 meters. Feel free to pause the video and double check the math to make sure you know how to get that. And we will continue on. So now we know that, we can start taking our sum of forces in the moments. Sum of forces in the x are equal to 0, positive x direction. We get negative force BC minus force FC sine of, now I'm going to put this as beta. Now I'm labeling my beta, go back over here, I'm labeling this angle right here as alpha, this angle right here is beta, and this angle from the horizontal as theta. I will show you what those values mean in just 1 second. I'm going to go ahead and finish out this equation. Force EG cosine, is it EG? No, FG. My apologies, I wrote it wrong. FG cosine of theta is equal to 0. To find those angles, theta is equal to inverse cosine of 2 over 2.166. Now that 2.166 is coming from, on this part of the triangle, this one right here is 0.833. I do that by solving 2.5 over 1/3. So this one is going to be 2.5 divided by 2/3 to get 1.66. Yeah, so I actually have a typo right here. I'm going to readjust that. I'm going to start this off at alpha actually. So alpha, my apologies guys, alpha is going to be inverse tangent of 1.667 over 2, which is 39.8 degrees. Define our beta, it's going to be 90 minus 39.8. We get that to be 50.2 degrees. Okay. Going back to our equations, sum of force in the y is equal to 0. We get a negative 25 kilonewtons. I'm just combining the 12.5 kilonewtons into one force. That way, because it's just sum of forces. Minus force Fc cosine of beta minus force Fg sine theta is equal to 0. Now, I've got too many unknowns, so I need to take a sum of, not forces again, but moments. I'm going to take a forces moments about F. Now, I know that I made my cut and you can't see F in this problem. F is somewhere outside over here. I can still take a moment about those even though it's not part of my cut. So doing that, we get force BC times 1.667 minus 12.5 kilonewtons times 2 meters minus 12.5 kilonewtons times 4 meters, all equal to 0. Now I can solve for force BC. Force BC is 45 kilonewtons. But I still have too many, I have 2 unknowns and 2 equations. So the easiest way to do that is going to be solving them into a matrix. We get force Fc sine of 50.21 degrees, force Fg cosine of 22.62 degrees. Now, you're going to be asking me where you're getting this theta, you know? So, to find theta is going to be to what I was going to be actually trying to do earlier, which is inverse cosine of 2 over 2.166. Double checking that math. 2 over 2.166 is 22.62. I'm a little off. That's probably because I'm in the wrong mode. But just watch out for your calculator mode. Make sure you're in degrees, not in radians for this section. That way you get your numbers right. So theta is 22.62 degrees. Okay. Continuing on, we get force Fc cosine of 50.21 degrees and force Fg to be sine 22.62 degrees inversed by negative 45 kilonewtons and negative 25 kilonewtons, all equal to our zero matrix. If you get any kind of confused or stumped on this, feel free to take a pause on this video, go back to my video over my TA84 to how to put a matrix in. It's going to be the exact same format. All you're doing is inputting in your sine and cosine values in on your first matrix, and then your 45 and 25 in the second matrix. All it is a 2x2 by 2x1. Solving the matrix, we get force Fc and force Fg to equal negative 19.53 kilonewtons compression and negative 32.48 kilonewtons compression as well. Okay, and that is it. If you were attending the live SI session that we hosted, you probably missed out on a little bit. We had a little bit more deeper explanation than these videos. So my best tip is, if you can, please try to make the live sessions. I can actually see you in person, talk to you in person, and we can have better communication so I can help better explain things. While I'm on this computer doing these videos, there's only so much I can remember or write down to explain in these videos. So if you have any other questions, please feel free to shoot me an email or a text. And that concludes our Chapter 6 review and our entire Exam 2 review for Statics Exam 2. Again, if you have any questions, feel free to shoot me an email, send me a text, and I'll be more than happy to help. Other than that, good luck everyone, and hope they all do very well. Thanks.